so this is about rate law and what rate law is and how to calculate or determine the rate law of your reaction. So remember, rate law is all about your kinetics, and kinetics is about the speed of your reaction. How fast does something occur? So to understand rate law, why rate law is special is that it actually allows you to do a couple of things. So number one, if you have developed your sort of your rate reaction, it's basically just the rate is equal to this constant times your concentration to a power of a number. So what does that really mean? What rate law allows you to do is that it allows you to relate the concentration of your reacting species to give you the rate of reaction. So what that means is that you can actually safely assume that by knowing the amount of the concentration amount of your reacting species, you can use that concentration amount to relate to how fast your reaction is. So if you know the concentration, then you can pretty much calculate how fast or slow that reaction is. And also in rate law, it allows us to calculate, well, that's what I just said, allows us to calculate the rate of when concentration is provided. So, like I said, the calculation depends on the concentration. And lastly, the specialty of rate law is that it allows us to quantitatively determine how fast or how slow something is. So what I mean by quantitatively is that if you think about something like a nail rusting, if you think about how slow that reaction is, right? We know qualitatively that it's really slow, but how can we quantify that? How can we exactly put a number of how fast or how quickly rust is forming, like per minute or per hour? That's what the rate law does if we know the concentration of what's there to create the rust. So that's what the rate law is. So if you look at the breakdown of rate law, if we were to just look at very simple reactions such as just A decomposing to form the products, and to form that sort of the rate reaction or equation is that the rate is equal to K times the concentration to the power. So what's going on here? Again, rate is always going to be something per time. So your units are usually going to be moles over a time unit. So whether it's seconds or minutes or hour, it depends how quickly you want your rate to be measured in. And K is the constant, so this is to give the proportional to the concentration of your reactant species. That is only determined experimentally, so only if you have experimental data. And then the square brackets with the A is that it's the concentration of your reactant species. This is just like your equilibrium. And lastly, it's the X or the exponent, which is the order. The order plays a really important role in determining your rate because it affects how fast your rate is. So basically, your concentration affects the rate, but the order really is the one that's affecting the rate. And you're going to see that in for our orders, we have three different examples, I guess. And one is order is equal to 0, one is order is equal to 1, and the last one is order is equal to 2. And these are basically, when we say order, that's just the exponent that's the concentration is raised to. So let's look at each of them. If we have the rate of 0, that means that we have an exponent of 0. And what does that mean? Well, if we were to substitute, let's just say if we had a concentration of 4 for the reactant species of A, this 0, that's the order, that becomes your exponent. And if you do the math, you can see that the rate, well, it actually turns into 1. So what's the effect? Let's just try another number just to try it out. Rate is equal to K is, let's use 100 to the power of 0. Well, this becomes 1 as well. So you're going to see that the order of 0 actually has no effect on your rate. So if you have something that has an order of 0, it's not going to affect the rate. So if you, to repeat that, if you have the concentration of A, if it has an order of 0, it's not going to affect your rate of reaction. And if we were to look at the next one, order of 1, and you can sort of see that if we were to substitute 4 into the concentration again, this is raised to 1 will give you 4. Let's put 100 as the concentration. 100 to the power of 1 will give you 100. So that means that this is proportional. What does that mean? That means that however much you're going to increase the concentration, that's going to increase your rate. If you're double, your concentration, you're going to double your rate. If you triple your concentration, you're going to triple your rate. So this is if you have an order of 1. What happens if you have an order of 2 when the exponent becomes a 2? Well, you can see that it actually increases quite quickly, because if we have concentration 4, this is going to be raised to the power of 2, this becomes 16. So that means that that concentration of that reacting species is going to affect the rate quite a bit, because it has the order of 2. Basically, the larger the exponent, the larger the order, the more it affects the rate, and the smaller one, especially 0, well, it doesn't matter. You can have lots of that concentration of this one, but it's not going to affect it. So to recap, order of 0, no effect. Order of 1, proportional, and order of 2 will give you like an exponential effect on the reaction rate. So that's just the basics of understanding reaction laws. The next one, I'm going to show you how to determine it through some 2 sample questions. So see you later.